Blaney, and I'm here today with Mark Ashton and Dylan Oscan. So it's very much about a collaboration between design and chemistry. And just to sort of give context to the presentation is we're 3.5 months into the 6 months of the project. And in terms of the presentation, I want to give a bit of an overview on the motivation to it, the context of a design and fabrication approach that we have been developing and how that collaboration has grown with chemistry. Then sort of some initial material results or the development of the project, some initial material results and how we're sort of going to go beyond that. And very much sort of in the context of what that means in sort of design implications. So the motivation is really we have sort of got these linear design and manufacturing processes that predominate, and that results in significant waste and pollution. So in terms of the need to rethink those, is how do we create design and fabrication processes that have discourse and interrelationships between design parameters, material properties and fabrication mechanisms so they can keep updating themselves to address this issue of if products become damaged, they could be healed, if they become outdated aesthetically, or you need to tune it to become more bespoke within different applications, there's the ability to push update into materials. So the aim of the research project, or the proposal, was a good application area for this was cycling jerseys. So on long stages, these cycling jerseys do not adapt to varying weather conditions, the athlete working really hard. So how could you do or change the material properties of these garments to help performance, aid recovery? And then this is sort of almost something that was one target application, but through conversations we've been having can open up to, say, prosthetics and other sort of beyond that as well. Okay, so then in terms of how we're interacting with materials, we've developed a fabrication setup where we're using stimuli to interact with these materials. So we've got an array of magnets, and we can move these magnets up and down, and that impacts and informs these material properties that we're collaborating with chemistry to create different patterns. And the other aspect that we've got is we can melt these materials as well, so we can temporarily freeze update into materials, take them out of a tank, interact with them, put them back in to update them. So that's the development of a multi-stimuli system. A really simple parametric design tool where we can change the shapes. I'm a designer, so I just love pretty patterns and pictures, so we can change sliders and we can get global pattern changes. So something that is really rudimentary and simple in a digital format, you can't change the shape of the table if you want to host more people. Like, we impose form on these things. We can do it digitally, but we can't do it physically, so that's sort of where the steps are. In terms of the overall system, where we're at, there's no feedback, say with Jordan stuff, there's no feedback between machine learning or sensor vision, so it's quite linear in the sense of we have sensors, we're moving things with actuators, and we have these materials that are changing. The user or how you interact with them is kind of the feedback mechanism that. There would be aspirations to maybe go down a route of AI with that sort of itself self-update. So the process is we've tested loads of little materials on small scales with chemistry, and it was kind of to find Goldilocks' correct porridge of the criteria of does it move when it's liquid? So I'm using super technical terms here. And is it strong enough when it's solid, so when it's frozen kind of thing? And that would let us do more robust applications to say like prosthetics. If it snaps when it's solid, it's not very much use kind of thing. So we've been working through them and we found the right material. So the little bit of chemistry sort of going is it was about finding the right molecular weight of a polymer and certain ratios within that to be like that's the right porridge to use where it's flexible enough. And what you get is quite a lot of emergent properties out of it that you can associate as well to design demands. So we're getting surface textures, transparent and as rigid it is, that can be mapped to certain applications that we're sort of trying to do through various workshops. So these are some initial results from the thing, from a different material sample to scale up from the setup that we've got. So it demonstrates self-healing. So then I would say we can move magnetic patterns into position so we can change patterns, and then this starts to attract these magnetic sort of particles. Again, I'll try and whiz on. Something as well is how you document these materials, so using a lot of videography and time-lapse to really highlight the dynamic properties of it. So then on this bit we'll change the magnetic positions. These sort of I was quite surprised at how much material height and volumes you get. Again, it's quite simple stuff, I think. That will just change the patterns. It lets us interact and iterate and keep changing the materials, which is something quite novel. Then what we find over, I'll skip ahead, is so over, say, time-lapse, then you sort of actually see the material separations as well, and then these could create like functional gradients if you can map them to, say, sensor values. This is the material freezing that we can take out, and what we then start to see is you can get very high-resolution material properties, so different surface textures, reflectance, transparencies, volumes. So actually just through some simple interactions, it's how you then map them to different applications, so why they're desirable. This is a second iteration of interacting with it, so then this just demonstrates we're able to melt it back down, we can interact with it again, so it doesn't become redundant. It's not just a one-hit product again. The interesting part about this is, though, and this is where I start to talk about implications on design, is there's actually like material legacy within this, so you can see previous patterns from the first iteration. So there's implications of legacy with material when you interact with stuff like this. So how do you reset a material as well? So there you go. So if I pause here, those are the patterns. That was the first iteration, and then the second iteration, when you act with it, you can sort of see this legacy of patterns. So does that hinder future sort of interactions? Is there sort of traceability to it? Is this heritage of material interactions desirable? So these are just some initial reflections that we're going through as well. Sorry. So then this is the aspect of, say, resetting the material. I love a low-tech solution, so just do it with a spatula, why not, as opposed to just, because it's just sort of, it's not to have technological login or lock-in where people can't interact with this stuff anymore, so what sort of an aspect of user-friendliness. And I used to feel guilty about doing like low-tech interactions, but actually there's sort of literacy in that and its value in that as well. So just some material results demonstrating, as I say, the various properties you get, aspects of resetting it, and the sort of legacy in there. Something that's also interesting is there's time lag in the material between, you can get real-time sensor information, but the materials don't respond instantly to the sort of the rate of the sensor information. So actually that means in this stuff, like the human body, your material adaptations will be based on averages, as opposed to potentially in situ responses. So there's interesting aspects on that, and that can certainly fine-tune what applications you go for. Maybe it doesn't make the sports jersey redundant because it would need to respond in situ on demand, whereas it's maybe the sweet spot, say, prosthetics, where the user can interact with it and update it over time based on slow demands that they have. So in terms of doing that, we're starting to develop tangible user interfaces to determine what materials do that in order to determine what sensor data we need. We're collaborating with some industry partners to sort of map what demands they'd need and material properties thereafter. So we're in those stages. And the benefit of that would be, so this is the work that Dylan's been on with as well, developing what a simple user interface would be to more speculative things, is the ability to make products more bespoke to the users as well over time. So as it's almost aging with your products if you're wearing them as well. So that's where we're sort of targeting that and the reason behind it. We're also using bioplastics for that, so sort of looking into how we'd cast with them, embed sensors through that kind of thing, and just sort of again moving away from these static, non-sort of degradable materials into something that's more environment friendly. So this raises up sort of, again, I'd bring it back to design sort of principles of like the role of design tools, how you interact with materials, what are the desirable material properties and for who, especially as the material properties become broader in palette. If the application becomes broader as well with multiple stakeholders. So what would that look like in a city, an adaptive city that can grow with multiple stakeholders? What does a city look like for someone that you can interact with and adapt? Would be very different for each other compared to a single garment or a prosthetic. So that's quite interesting. Feedback mechanisms, integration and exchanges of matter as well, when you can sort of, instead of having, with the linear processes, carbon keeps getting output, but there's carbon cycle in biological systems, so it's a valuable resource. So how do you sort of close the loop on that? And then I was sort of saying, implications of material resolution when you sort of go, I'm going to use noise, I'm going to make messy fabrication, and that's very noisy. but you get higher material resolutions out of it, like sort of human biology. There's implications with that though. There's lag, there's legacy, and you need to reset these materials. And that's me.